All right, rationalizing the denominator. So one of the rules about simplifying, radicals, we can't have any sort of denominator that's radical. So here I have 4 over the square root of 3. This first one's real simple. It's a big time review. You've done it in geometry, okay? But it's a good thing to lead up to this one that's a little more complicated. All right, so we have a square root of 3 on the bottom. Now, in order to make the square root of 3 rational, what you can do is multiply by the square root of 3, because that would equal the square root of 9, which is regular 3. We would have this pair of 3's coming up, okay? But you can't just go around multiplying the denominator by anything you want at any time. If you multiply the denominator by radical 3, you have to multiply the numerator by radical 3. Why am I allowed to just go around and multiply by something by radical 3 over radical 3? Because that's anything over itself is 1. And when you multiply anything by 1, it doesn't change its value. I went to the bank the other day and I said, I demand you to multiply all the money in the bank that I have by 2. And they refused. They said they wouldn't do it. And they said, fine, I demand you to multiply all the money that I have in the bank by 1, and they gladly obliged. And they gave me the same amount of money that I had. Because when you multiply by 1, nothing changes. It just changes its form a little bit. All right, so now 4 times radical 3 would be 4 radical 3. And then radical 3 times radical 3 is radical 9, which is just radical 3. Now, the denominator is rationalized, okay? This is acceptable. This was an equivalent expression, but not acceptable because the denominator was in a radical. Don't ask me why. I don't know why they said the denominators can't be radical. I just work here. Don't get mad at me. I don't think it's that important, but somebody says that the denominator doesn't look right if it's radical. All right, now, this one here. Look at this one. If I have a 4th root, how many 5s am I going to need to pull out a 5? Okay? I'm going to need 4 of them. And I only have 1. So how many more will I need? I will need a total of 4 5s. So I'm going to multiply on the bottom. Remember, if it's one big radical over everything, it's the same as if you have a radical, and the roots are going to be the same. But I'm going to multiply this by the 4th root of 5 times 5 times 5, or 5 to the 3rd power. If I multiply the denominator by 5 to the 3rd, I also have to multiply the top by 5 to the 3rd, because then I'm multiplying by 1. So 125. Is that equal to 1? Sure it is. Because this is the same as this, and anything divided by itself is 1. All right, so I multiplied by a version of 1 that's going to rationalize this denominator. But let's see what we have here. When I multiply the top, 3 times 125 is 375. So I have the 4th root of 375 on the bottom. On the top, I'm sorry. On the bottom, I have the 4th root of 5 to the 4th. Well, now, do I have enough 5s to bring out a 5? Do I have enough 5s to rationalize that denominator to make it a rational number? I do. So I have the 4th root of 375 over regular 5. That's it, rationalizing the denominator. That one takes some practice, but we're going to get some practice, so I'm excited. All right, next video is coming up.